Welcome to all the distinguished speakers and the participants on behalf of Bangalore Chamber of Industry and Commerce. We welcome you all for this webinar on purpose of industrial automation and emerging job roles, organized under the joint aegis of Industry 4.0 and Industry Institute Interface Expert Committees. We welcome Mr. A.N. Chandramouli, Chairman of our Industry 4.0 Expert Committee, for initiating this session and who is also the speaker for the session. We also welcome Dr. Devarajan, our President for the year, and who is also the Senior Vice President of TVS Motor Company. Welcome, sir. And Mr. Rabindra, sir, who is the co-chair of our Industry Institute Interface and Edutech Expert Committee. Welcome, sir.
Thank you.
Thanks all the participants once again for joining this exclusive session. The Chamber acknowledges the support of our annual sponsors, Mrs. Bueller, Continental Automotive, Fundamax, IAMPL, MTR Foods, Sona Group of Companies, SDMIMD, TVS Motor, Vishwas Group, and Wipro for their support in all the activities of the Chamber. Now I would request Mr. Rabindra sir to take it over from here. Over to you, sir. Thank you.
Thank you, Rupa.
Thank you, Rupa ma'am. And welcome to all the participants this the webinar. Before I start the webinar, I would like to introduce our speaker, respected A.N. Chandramouli sir, and we call him a Mouli sir. And sir comes with more than 4 decades of industry experience, and he has worked for across the industry and across the domain in his career. To talk about it, that sir has been the CEO of Mechanic India, MD of Lab India, and then the business head of the Hitachi and Home, operation manager of Unilever, and so on and so on. And he has been in the board. He's in the board of the many of the company. He is the former president of the Bangalore Chambers of Industry and Commerce, and many more. And he is associated with the sector council, etc., to name a few. I welcome you, sir, to this session.
Thank you.
And
Thank you.
I welcome our president, Dr. Devarajan, sir, for your encouraging word. I would like to request you to say a few words before I hand over to Mouli, sir.
Yeah. Good morning, everyone. I think thank you very much for joining this program. Just about a BCIC, Bangalore Chamber of Commerce is a leading institute, in terms of in Bangalore and in India, and now extending to Japan and other areas. BCIC has got 5 or 6 major activities in terms of outreach, government interaction, special projects, industry academia interface, and other activities of the government. We always tend to connect with people, connect with all of you in terms of the way activities is going on in our country. And we have 28 expert committees across areas. I think today you see integration of industry institute interface and IoT, with both chairmen are here in this on the screen, what you can see. And we have many other 28 expert committees: agro, banking, corporate, CSR, direct taxes, environment, manufacturing, industry 4.0, like what we are seeing today, semiconductor, coordination with state committees. There are 28 expert committees. You can see a lot of programs coming from BCIC, a lot of webinars, a lot of contact programs, and definitely we encourage all of you, including students, including the institutions, to become member of Bangalore Chamber of Commerce. Today is a very interesting topic we are discussing. Why it is important? See, India is becoming, in terms of globally, getting into the top 5 of GDP, getting into top 3. The major thing is how we can be competitive, how India manufacturing can be competitive. To be competitive, there is definitely a requirement of quality, cost, delivery. In today's context, time is taking into major focus. How we can be on time, how we can be ahead of time. So I always try to say, whatever we do, how we can be made better. So it is time focus on quality, time focus on cost, time focus on delivery, on whatever you talk about, flexibility, agility, whatever you talk about it. Hence, automation in terms of how to improve productivity, how to improve the output on time, how to improve the output on time, and how to be agile, which is important for the customer, because all of you are customers for many of our products, many of our areas, many of our requirements, including the institutions, including the education institutions. So automation in all the areas, direct area, indirect area. If you have ChatGPT, how you can use it better, how you can get the output better, how you can make decisions better. So all these things are coming under automation. And to do these things, the skills are becoming very, very important. The skills of engineers, skills of operators, skills of anyone you take is becoming very important. And to improve the skills, the roles and responsibilities have to be defined. And in changing conditions of digital, changing conditions of automation, changing conditions of expansion all over the world, how you can define the roles and responsibilities clearly to deliver these roles and responsibilities. I think it's a very, very interesting topic, and I can't wait more for listening to Chandramouli and Rabindra sir to take it forward. Thank you very much, sir, for making this happen. Thank you,
so
Rabindra sir, for making it happen. Let's take it forward and let's make India great in terms of activities. I request all the participants to put their points in chat box, interact more. We strongly believe that more interaction, more face-to-face discussions will always help. And let us take it forward from here. Thank you very much, Chandramouli-san and Rabindra-san. Take it forward. Thank you very much.
Thank you so much, sir. Thank you so much, sir. Sir, sure. Just to mention housekeeping, all participants are requested to share the questions and the queries in the chat box, and appropriate time I will take up with the speaker, Mouli sir, or maybe toward the end of the session. So stay connected, keep on sending the chats, questions on the chat box. Thank you so much. Sir, now I'd expect Mouli sir to take it forward.
Thank you. Thank you, Rupa, Madam, Dr. Devarajan, almost Dr. Rabindra Saha. Yeah. So I think it's a great August group. We have 25 people joining, more people are joining. And even if somebody could not join, we will ensure that the video is available to go across the nation through YouTube and LinkedIn for the benefit of the students, the fresh students, as well as the apprentices in the industry, as well as the people who are getting upgraded in their own respective job roles. So this will be an introductory program. Many more programs are planned by myself, Jagannath, and Mr. Saju from ABB, Jagannath from BFW, M2 Next. Our co-chairs, very erudite people. Mr. Rabindra Saha is interacting with the institutions. He is a great leader from Tata Technologies. Thank you, sir. And Dr. Devarajan himself, leading us from the front. So there'll be at least 12 programs in the year and another 12 visits to the industry being planned, and that schedule will be circulated very soon. Without much ado, let me get into the master class, right? I'm still learning on the subject of industrial automation, factory automation, etc. So to call it as a master class, I think it's too humbling. So let me just start and share my file, and the logistics also you can take care. If the audio and video are coming up, somebody can thumbs up, right? So let me go into, yes, computer sound is on. I'm going into the window. I'm going into. Are you all able to see the PowerPoint slide?
Yes, we can see, sir.
Is it a full view or it is?
It's a full view, sir.
All right. So I think things are happening today. Internet is cooperating at my home. Working out of home is what I learned during the COVID. Let me just give a small introduction. I think anything we do in our work life, or in the area of industry or business, what is very, very important is what I call as the purpose of doing it. The why of it is more important than the how when, what, etc. The who, of course, comes definitely because the people who are going to implement it. But today's focus is primarily the why. Yeah, you can't cover more than that in 90 minutes. So that there are many whys which I will address. There are many videos students will enjoy and they can make notes. In a normal class, we would ask them questions about the videos. But today, online interaction difficult. And definitely emerging job roles. We want more engineers to move into manufacturing sector rather than IT and other sectors. So what are the emerging job roles? Well-paid job roles, right? It is not anymore 25,000 rupees per month. You can start your career at 50,000 rupees per month. So, Rabindra, am I moving to the next slide? Is it coming?
Yes, sir.
Future and emerging job role slide is visible, right?
Yes,
okay.
Sir.
No one, I will not ask. I think its navigation is happening. I think in this slide, you all will see there are at least 10 boxes here. What are these 10 boxes? These are the future and emerging job roles of the Industry 4.0. I use the word Industry 4.0 deliberately. I'll explain a little later. While I'm talking about factory automation as a primary subject today, there are two inseparable twins. The factory automation and the digital manufacturing are the inseparable twins in the era of 2020 onwards. I think we are talking about G20, G21, right? Africa also joined. So we cannot just talk only automation, which primarily started in Industry 3.0, but together with the digital manufacturing, yeah, the two stars. But I added a third star. You may be wondering, what is this third star? Smart mechatronics engineer, right? I think our good friends have joined here who are the leaders in the mechatronics industry. And this, I believe, is a foundation of both factory automation and digital manufacturing, right? And it is indeed the foundation of the other job roles: predictive maintenance, digital quality, digital design. Digital design is not only CAD/CAM. Digital design allude to the PLM concept. I think Mr. Rabindra Saha will conduct a class later on. He is a walking library of PLM, product lifecycle management concept, which is very, very important in the modern world. How to connect design to after sale service through one platform, where design takes a center stage, if you like. So digital design, data analytical skill, very important. It applies in all these job roles. It's a common one. Additive manufacturing is not only a new technology, it is converting the bytes into bits, right? So it is kind of a 3D printing is no more an unknown category. It's a modern technology, is an emerging technology. At the same time, it is catching up very fast. Cyber security cutting across, yeah, very important area. You can't have technologies without the security aspect, right? And data corruption should not happen. And above all, there are interesting topics, new technologies called augmented reality, which try to combine the power of product lifecycle management and the power of the Industry 4.0 to get to subjects like remote maintenance, remote assembly, remote training also, and so on and so forth. But I put the 3 stars. The reason I put the 3 stars, although all of them are stars and there are many more, there are indeed 45 job roles, including automation and 4.0. And these 3 stars will create at least 1 million jobs in the next couple of years. With G21 behind us, you can see this happening. And you may wonder how more jobs are created by automation. We'll take it up in the Q&A. Is a teaser, so we'll take it up in the Q&A. Without much ado, I move into the subject now. Rabindra, I think it's visible, right? And so this topic of factory automation,
yes, sir,
is a skill pyramid. On the one hand, I call it as a pyramid of technologies. On the other hand, I call it as a pyramid of job roles. On other hand, I call it the skill pyramid also. The pyramid is got a very important connotation because the lower end of the pyramid is a foundation. It is not a lower skill. Please understand. These are the very important elements of automation. The pneumatics, hydraulics, mechatronics, as we call it, the drives, PLC, CNC, human machine interface, many more like this, vision technologies and whatnot. And these are the foundation. So that is the reason it is at the bottom of the pyramid. Second reason, the number of jobs, my dear students, the number of jobs in this area are far, far higher than in the areas above in the pyramid. By the definition, you will start your career here, and as you move up the ladder, you will move into these job roles, which are more holistic in nature, partial automation, which includes robotics and autonomous mobile robo and other concepts, flexible automation concepts. I'll explain that. And the icing on the cake is a smart automated factory with IoT, augmented reality, data analytics, digital technologies. I call it as the icing on the cake. The bread, butter, and the jam is another way of looking. The volume of employment will be inversely related to this pyramid, and the foundation of knowledge and the foundation of the skill is again directly related to this pyramid. And this is, I'll explain at the end of the session. If time permits, I will take you through a job description of a factory automation job. And also I'll talk about a job description of smart manufacturing, digital manufacturing job. Since I put it at the end, it all depends on the time available. We lost already 15 minutes on people joining. I'm moving on. Why automation? You can type your views in the chat box. As organizer told you, let's move on. As I already mentioned, the two inseparable pillars. In one is automation. Yeah, Rabindra, visible. One is an automation, robotics, etc.
Yes, sir. Yes, sir. All visible.
Right. And another is a digital manufacturing. IIoT is a backbone, industrial IoT. There is a retail IoT, there is a commercial IoT, there is a service sector IoT, but here we are talking about a classification of IoT, which is called the industrial Internet of Things, which is a body of knowledge totally different from what we talk in the case of Ola car and Zomato, etc. But that is all in the retail and commercial sectors or even e-commerce sector. But here we are talking about industrial manufacturing sector. IoT is a very important domain, and flexible automation and intelligent automation. You know, the adjective intelligent automation already subsumes the digital manufacturing in one sense, right? So there was a question I found. In fact, very interestingly, people have sent questions to BCIC even before the webinar started today. There are some 40 questions I received this morning. We will address it later on in an offline basis because it's very, very interesting questions. One question is, how do we link automation to Industry 4.0? This slide will answer you, and later on some explanation of these slides. Flexible automation, you can see multiple robotics, right? Unmanned situation. And industrial Internet of Things makes it intelligent automation. If I enable this robots with IoT, yeah, it's a simple example. Automatically, you get into intelligent automation. I'm moving on. Why automation? Right? That's about the what of it. But quickly, I'm coming to the why of it. There are 4 boxes here and there is a triangle here. You know, the students will appreciate some pictures. They love all these pictures and all. Lot of text is not the way I would like to do master classes. I request BCIC and the experts to look into this concept. Right? We can even train people on doing these kind of things. We have to look at the 4 major objectives of automation. These are quality related, delivery related, as Dr. Devarajan mentioned. Time dimension is extremely important, and cost related. Cost would include even efficiency, productivity, anything to do with internal to the organization. The cost related is internal to the organization, right? It may not be visible to the customer, but indirectly is affected by it because the pricing and other value propositions are affected by cost. So even all these 4 things, 3 things I mentioned, the 4th one I'm coming quickly. Consistent quality. You all maybe heard of the quality dimension in any product or social sector, whether we go to a hotel, have our food on the roads, we don't want potholes. So quality is an all pervading situation. When it comes to automation, we have to add the adjectives are more important. Consistent quality, repeatability. Whether I produce 1 component or 1 million component, 1 tablet or 10 million tablets. For the COVID, we sent billions. I think it's several billions of vials were sent all over the world. Can we achieve a consistent quality through a repeatable process? That is where the automation is extremely important. as Dr. Devarajan mentioned, can we achieve a faster response? Customer gives order, you deliver the order. The faster response to the order. Customer sends an email, you respond to the email. Customer makes a phone call, you reply to the phone call. So whichever it is it a product or a service sector? Hotel, you go and order the food, Zomato delivers in 3 minutes, right? In those days, they talked about 7 minutes delivery of pizza in America. Faster response, throughput. Throughput means end-to-end time taken from the start of production to the end of production of a two-wheeler, of a four-wheeler, of a pharma product, whatever it is. From the end to end, from start of production to the end of production. The time dimension. I'm just laboring on this slide a little bit because you have to clear this fundamentals. And production efficiency. It could be a man, machine, material methods. Manpower efficiency, utilization of machines, yield of materials, wastage of materials, and how the methods can be very productive. All these are covered in the productivity box, right? And last but not the least, quality, delivery, and cost are a given guaranteed approach for the last 60 years. But the new emerging factor, my good friends, ladies and gentlemen, the new emerging factor where automation is inevitable is a very high flexibility. I will illustrate with a video and explanation later on. Very high flexibility. You go to the masala dosa and order any types of masala dosa. There is a hotel in Bangalore called Foodies. They have 45 types of masala dosas. So even whether it is social sector or manufacturing sector, there is a very high level of variety being handled, right? My dosa example is for you to get a flavor of not the dosa, but the concept. Very high flexibility. This box alone, in my opinion, can drive the automation. And this is not necessarily only for developing world like America and Europe, etc. Today, the number of components being produced by third world countries, so-called third world countries, or developing nations or underdeveloped nations is much more than what is being produced by the developed nations like Europe and Germany, Japan, and America. The components are of very high variety. Auto component industry, if you take, each company is producing 200 types of clutches and brakes, 400 types of gears and gearboxes, at least 100 types of engines and engine types. I'm talking, not numbers. Numbers are in millions. So therefore, the 4 reasons for automation, right? Being very fundamental, I stayed on it for a few minutes. Let's move a little faster. At the same time, the shorter lead time, minimizing cost and highest quality. And then 4th weapon called flexibility, already I mentioned, are very, very important in the concept of lean manufacturing. Some of you students might have heard of the lean manufacturing concept. Is it different today we are talking? No. Lean manufacturing is a fundamental foundation requirement. I hasten all the colleges and training institutions to teach lean manufacturing even before teaching factory automation. And now it is becoming even more important. The 4th weapon of flexibility is not adequately covered by lean manufacturing principles. Because in the good old days when Taguchi Ono created lean manufacturing and Toyota production system, the varieties of cars were not that many, right? And now we need to manage the fluctuating demands over time and space and customized demand over time and place. This explanation of flexibility requires a separate masterclass. It's just I'm giving you a hint on what is this talking about, customized and fluctuating production demands. During COVID, you know what happened to the factories. Very high level of fluctuation of manpower available to run the factories. And before COVID, after COVID, and during COVID, the human beings want enormous variety of products through e-commerce and even otherwise. So we need to understand, can we address not only quality, delivery, and cost, but the flexibility as a 4th weapon. And now I move on to the traditional approach to understanding automation. Again, why of it? The Toyota production system. My good friend T.R. Parasuraman sir, who is a walking library of Toyota production system, and Devarajan sir talk about 6 losses, then 12 losses, 16 losses. I came across a recent note talking about 24 losses. right? I'm not going to read out these points. I can share this deck through a LinkedIn, right? And then BCIC can circulate it to the people who participated. Breakdown related losses, machine breakdown related losses, material setup and adjustment during manufacturing. You have to change the components. You have to do setup and adjustment from one component to another component. You're changing over, right? I think the people in the working industry will understand this point. Students may find it difficult. Another class we need to have to explain this. Small stoppages happen in the production due to various reasons. Speed can be reduced due to some problems in the shop floor. There can be quality related rejections in the beginning of the production. When the prototypes are being made, we call it startup rejections. We welcome startup rejections, but we don't want production rejections. During the mass production also there are rejections. Sorry, spelling mistake. There are many rejections in MSME. The biggest focus here is startup rejection and production rejections. MSMEs are always talking about productivity, productivity, productivity. When are they going to talk about quality, quality, quality? The rejections is the biggest drain on the profitability of MSMEs, small and medium enterprises. Even today, in spite of 4 decades of manufacturing revolution in this country, we still have this big problem of rejections, scrap, rework, in process, expired material. There could be expired material even in the field, like in the pharma industry, right? How do we manage all these losses, the 24 losses? The factory automation helps to eliminate or at least minimize these losses in manufacturing. And the fundamentals of Toyota production system or lean manufacturing system is to eliminate these losses. When you remove 1 rupee loss, you get 1 rupee profitability improved. Profit improvement doesn't mean only going and getting better prices from the customer or improving the volumes of sales. The biggest profit improvement under our nose in manufacturing, are these losses. I hope some of the MSMEs joined today or listening to this point, right? And later on, I think we will send it to Laghu Udyog Bharati and other people. Yeah, Rupa? Are the slides
Yes, sir.
visible?
Visible, sir.
Yes, sir. Yes, visible. We'll do that,
From
sir.
that 24 losses, why am I coming quickly to this big chart here? When you eliminate these 24 losses, we get what is called a overall factory efficiency. The word OEE is overall. O is overall. E is equipment. In this case, many equipments lying in the factory, so entire factory. If it is a conveyor line or an assembly line, entire line. If it is a pharma and FMCG factory, food and beverage factory, or cosmetics and detergents, entire line or entire factory. Overall equipment, effectiveness. Effectiveness means they should be performing at the desirable ideal target rate. That's the concept of effectiveness. Effectiveness also means satisfying the customer requirement. There is a big confusion between efficiency and effectiveness. In another class, I will explain that in detail. Efficiency is what is visible internal to the organization. It's about cost reduction, waste reduction, loss reduction. That is efficiency. Whereas effectiveness is satisfying the customer in terms of the quality, in terms of the delivery, in terms of the cost, in terms of the price, value, and also flexibility. To do this, there is a classic way of measurement acceptable across the world. Acceptable across the world. And that is called overall equipment effectiveness. I don't want to explain these formulas here, right? Then we lose some time. Today's overview only. Yeah, I'm watching the time. 11:30 now. When the machines are under breakdown, the machines are not available to produce. In a 24-hour production or a 8-hour production, 480 minutes of production, the machine is down for 120 minutes. So you are getting 360 by 480, 75% machine availability. In that 360 minutes, assuming that I'm producing 10 components per minute, I can produce 3,600 components of any product. But instead of producing 3,600 components, due to many reasons I mentioned in the previous slide, the production losses, I end up producing only 2,880 components. It's just an example. That means actual production divided by possible production is only 80%. We call it performance rate. And now this 2,880 actual production, there are at least 5% rejection. That means around 44 components rejected. 44 components are rejected. 95% is a quality passed rate. That is called quality rate or passed quality rate. Imagine now, out of 480 minutes, 360 minutes I am producing, 3,600 components I am producing, 2,880 only, or I'm not able to produce 3,600 due to the losses, out of which 5% are rejected, scrapped. If you multiply the availability, performance and quality, you get only 57%. What is this 43% gone? It's gone due to the breakdown of the machines, due to the losses in production, and due to the rejection in quality. 43% is a huge amount of capacity lost by factories. Now automation helps to improve these things. I'm still talking about the purpose of automation. If you say, sir, how it is helping? Another masterclass Jagannath will conduct, another masterclass Saju will conduct, and so on and so forth, and Rabindra Saha and all. The quality consistency, decoupling human fatigue and errors. Obvious point. Human beings tend to make errors. Productivity performance, when I use all the idle and handling times effectively, there is no idle time. There is no loss of production. When I'm able to improve the availability by decoupling the machine tool and the operator, 24/7 operation, I will play a video for your benefit to understand the last point. So when I do these kind of automation, I get improvement in availability, improvement in performance, improvement in quality. Now the global average, sad to say, it is only 65%. The global average is only 65% against the 57% shown in this example. Now the G20 and G21 kind of people should discuss how to improve the global average to 85%. In fact, there was one Commerce Ministry of Central Government conducted a workshop how to improve the OEE from the global average of 65%. At least India can it go to 85%. 100% is extremely difficult, and automation is one of the answers, key to this answer. Let me move on. Now the very interesting point about purpose of automation, right? We are still on the purpose of automation. In the next 20 minutes, I will show you a couple of slides. There are 5 purposes of automation other than whatever I told so far. You have to keep adding whatever I said. First purpose, second purpose, third purpose, fourth purpose, fifth purpose. These 5s are dull, dirty, difficult, dangerous, and distancing. The dull, dirty, difficult, dangerous, and distancing. What are these 5 Ds? Let us explain. Dull. Yeah. Rupa, you able to see the slide?
Yes, sir.
Clear,
Yes.
sir.
Imagine this person constantly keep on assembling the bicycle or the motorcycle. And if he's assisted by a robo, if he's assisted by a collaborative robo, or a robo, which is a non-collaborative robo, and the entire weight of this one part of the bicycle is lifted and he has to only concentrate on the other wheel and assemble it. A repetitive job like this is enabled in this. Let us move and see a simple video.
Introducing the Atlas Copco automated wheel mounting power head.
Yes, sir.
Our
Yes, sir.
machine vision system checks the orientation of the wheel and provides guidance to the robot. Watch as the lug nuts are now moved from the fastener presenter to the wheel with a gripper. The vision system performs a visual inspection to ensure all fasteners are in their correct position. Now, the AWM power head grips the wheel and our tightening system engages the head of the lug nuts.
Right. You know, it's a teaser. You got the idea that how a dull repetitive job is being converted into a comfortable job with the help of the robo, and also other benefits are coming, which I already mentioned: quality delivery, cost, quick response. You can visualize those things which I already mentioned in the previous purposes. The second aspect of the 5Ds, how to replace dirty jobs. You know, this man is wearing all this mask and other things, you know, gloves, special apron, then doing painting of a car. This is a 40 years back, 30 years back we were doing. We also do this in service industry, workshop, dealer workshop. We still do this, right? Europe have moved on in workshop, service workshop also, they moved on to automation. This picture is obvious. Let's see a video here. The brand Kawasaki, the brand Fanuc is not important.
We introduced the
on
Kawasaki Robotics
example.
KJ264. The KJ264 explosion-proof painting robot combines high operational performance with easy system integration for optimal results. It features a long reach and a 3R hollow wrist design with an inner diameter of 70 millimeters to accommodate larger hoses inside the robot. This prevents paint mist from adhering to tubes and cables, minimizing the risk of contaminants in the paint finish. Kawasaki Robotics also offers a control panel that simplifies system building and interfacing with peripheral equipment. The KJ264.
You got an idea about how a dirty job called painting has been improved tremendously by using a fantastic robo automation, right? The third example or the third reason for automation, difficult to do jobs, heavy handling, especially in the packing area, warehouse example you are seeing. But I will also show you some manufacturing example, right? Universal Robo is a global leader in this, but it's just an example. The brand is not important. And these are the how it was done manually. You can see what happens to his backbone. Over a period, he has to surgery. Lot of spinal surgery will happen. Yeah, and here he is cool. He doesn't even worry about it. Automatically is happening because the difficult to handle jobs, right? And see, this is probably this video will help you. Wow, such a heavy product. Other day we went to ABB, we saw such heavy products being lifted by the robots. I don't think any human being can do this. In the early days they were using overhead cranes, but overhead cranes do not have flexibility. They are not fast enough. They cannot change the program depending on the component. They are not flexible. Overhead cranes are not flexible. This is a real life example with Fanuc robots handling heavy duty components in the steel industry. I think that video was self-explanatory. The fourth major D, my good friends, is a dangerous area. Dangerous. You can see the welding. Yeah, all this goggles is wearing, gloves, and the welding. You know, sometimes you open and sees the life expectancy of the eyesight of this person. You know, definitely will be less than somebody else who's not in the welding area. So welding has been the first category for automation in the even Indian industry. Indian industry, there is no car manufacturer who do not use robotics for welding. That means every car manufacturer in this country are already using automatic welding apparatus as shown in this picture. And this has become more and more popular because the volume also growing in two-wheeler and four-wheeler industry, and other industries are catching up. At least they are doing some semi-automatic working. That day we saw in a company called Fronius in Pune, semi-automation. But a complete automation is happening very fast in this country. Already last 10 years, almost all the automobile industry are doing robotic automation in welding industry. Painting, welding, these are all the dangerous area, right? Let's see the video. Foundry. Foundry is another dangerous area.
KUKA.
I don't need to explain why it is dangerous, right? The other day in Ahmedabad, we went to one company where there is so much of hot furnaces, casting, forging. They have beautifully done the robotics there. They have done it 20 years back. And now they are modernized. Yeah, a couple of months back we visited this factory in Ahmedabad. And see how even the robo requires protection. It is not only the human being requires protection. There is a kind of a high temperature foil covering the entire robot. So the robot performance depends on a reliable performance of the robot without any breakdown. My good friend Jagannath says now more and more robotics happening in this country in foundering and forging industry. Not even in machining industry and all. This video is clear, Rabindra? Visible?
Yes, sir. Very well. Very well.
Because some other slide popped up in my screen, so I was careful.
This foundry automation is visible, sir. Video is better.
Yeah. So I think these are the illustrations which the 4 Ds are very familiar. But during COVID, my good friends, please understand, during COVID, another D happened, distancing. You see, even a robo is holding the man. Is an example of a collaborative robo. Yeah, he's handshaking. Literally handshaking means he is giving the program. He is doing the program of the collaborative robo. So that the distance between the two human beings is not affecting the pandemic, the spreading of the pandemic and any other disease happening. I believe even America, COVID is repeating again. It's come back again. There are other COVID diseases happening, other pandemic diseases happening. How do we increase the distance? During COVID in India, there is a 50% manpower reduction legally approved by Government of India. It is not a permanent reduction. Monday, Ram will work. Tuesday, Sham will work. Or week 1, one person will work. He will take off on week 2. That means 50% only attendance. And what they did in that context, they did not lose capacity. They introduced a COBO. They introduced a collaborative robo. Yeah, my good friend in Universal Robo very happy because during COVID, he got more orders of automation than less orders. Automation was accelerated and adopted faster in this country as well as all over the world during the COVID 3 years. And very comfortable. You can see 2 Indian women assembling something and later on we'll see some videos on this. Yeah, that's a video here. Beautiful music by Fanuc, Japanese company Fanuc-san.
My name is Mike Lambert. I am a controls tech here at FlexNGate. Robots are instrumental in production of any kind of product today. Working with collaborative robots is new to me since I got here at FlexNGate. Prior to that, I hadn't any experience with collaborative robots. What I've noticed with the collaborative robots is that they're really easy for the operators to work around and with.
At this FlexNGate facility, we primarily manufacture bumpers. In the past, we would have to put in cameras that would pick up every fog hole, every push pin, every FPA.
In one station, we've got 11, 12 cameras in there. Cameras can cost up to $10,000 a piece. With the collaborative robot, you have one camera and the robot moves the camera around to the areas where it needs to be inspected. Just in that sense alone, one camera versus 10, 12 cameras, there's a lot of savings. Also, just safeguarding for the traditional robot, all the fencing that you have to put around it, you don't have that anymore.
Our other robots, we have these massive cages around, and then on top of that, you have to have all kinds of safety locks and auto locks. All that costs a lot of money.
You save some space. With the traditional robot, you have to cage it all off for safety. With the collaborative, the safety is kind of built into the robot itself. It doesn't have to be a big cumbersome chunk of real estate that you're taking up. You can also integrate that in with your regular line and with your regular employees. So the operators can work closely to it and with it.
It makes it a lot easier for them and us, so they truly enjoy it.
We integrated the collaborative robot, and after we integrated it, about a week or so, I walked out there and they're working right next to the robot. As the robot's taking pictures of one side of the bumper, they're wiping off the other side of the bumper. And it's like, wow.
My dealings with the Fanuc robots this far has been nothing but great because we have very, very little downtime. They're compact, they're small, but, you know, they're mighty.
Service first guarantee on a Fanuc is an.
So you got a very good idea. The reason I played the entire video, this is a new emerging job role. If you are able to understand collaborative robo, my dear students, you will get 50,000 rupees salary even on day one. Collaborative robo programming and working with collaborative robo have to be taught in our skill development academies. That is even more important than teaching a fenced robo where you do programming and the operator is out. The human machine interaction is very low in a fenced robo. It is only during the programming, right? And loading the component is also automated, right? Now, before I go into this progressive automation, I just want to make a remark that we are not talking any brand here. Fanuc, Universal Robo, ABB, all are great brands. KUKA, these are only some videos I could lay hands on. And I thank them. I acknowledge these companies to allow me indirectly to present these videos. Thank you all the brands to present these videos. Now I move on to another reason for the purpose of automation. Purpose of automation, another reason, progressive automation. When you do automation, do you do immediately day one you want to do a robo? May not be. MSME small company will have a small conventional lathe. He has got a conventional lathe. There is zero automation. There is no automation at all. Operator is loading the component. Operator running the program. Operator is watching the component. I don't want to show videos because there's no time. And he is taking the component out. He puts in a bin. This is a conventional lathe. From there, we move on to the modern CNC lathe. Lathe means turning center. Modern CNC lathe. Yeah, great company in Ahmedabad, Jyoti CNC. They make fantastic products. They export also. There are great companies in this country. Ace Designer, right? And we have other turning center manufacturers, LMW and so on and so forth. And these are many imported products. 60% or 70% is Indian products, 30% coming from imported product. CNC turning centers. Why I show this? There is a little bit advancement in the automation. The machining process is automated. The loading and unloading of the component is not automated, but only the machining process is automated. Then I move on to the third example. Yeah, my good friend in Ludhiana, Marshall CNC, has done a fantastic innovation. They patented it first, then all others followed, and they went for a pendulum concept. Even the loading and unloading of the component and the loading and unloading of the cutting tools were automated inside the turning center. That called the pendulum concept. Even here, we are not talking a complete automation. Then comes our good friend, many examples where a robo-aided machining center is coming. You can see robotic automation coming slowly, and we will have this in several skilling development academies across the country, in this country, to develop people for robotic automation. Understanding robo separately is important. Understanding CNC machine separately is important. But in your job roles, if you want 50,000 rupees, 60,000 rupees salary, my good students, please understand the combination skills. I call it the multi-skill approach. Understand robo programming, understand machine programming, understand component application, which is called the application solution, and together you look into robotic engineer and this kind of people. You see the safety. This is a Japanese photograph. Everywhere there is a helmet, goggles, complete personal protection equipment. That's why I deliberately took this photo. In an Indian photo, you see nobody is wearing all these things. And last but not the least is a transfer line using gantry and using robos. In my career with Makinos and Starog, many examples we have installed with gantry and with robo. And there is a brilliant example in Tata in Sanand, where the nano car was produced those days, where the combination of gantry and robo, we call it gantry robo, supplied by a great company called Goodle from Switzerland. And the robo was Fanuc robos. The combination of Goodle and Fanuc robos came together And this gantry is a very important technology. We all should include in our curriculum and training centers. And the very, very important, people think automation means only robots. But there is a very simple and doable automation called gantries. And you can see this. 3 machines are operated through a material handling concept. And about this, we'll talk another day. So this is progressive automation. You start with nothing, gradually improve the automation. And this is explained in the next slide. Without much things, self-explanatory. In the first conventional turning center, all things are done by operator. Loading is done by operator. Machining is done by operator. Unloading done by operator. Transferring the part is done by operator. The moment I bring in the CNC machining center, I get loading by operator, but machining by automatic, loading by operator, transferring by operator. Then I bring in the pendulum concept. Yeah, operator, machining cycle, unloading, pendulum changes the component, and operator removing the component, transferring it. And then I move into robotic automation, right? Where loading, machine cycle, and unloading all are done by robo, maybe transferring by robo only. Then we get in the 5th category. If it is not so, then operator is handling it. That's the 4th progressive status. The 5th status is where everything is automated, either through gantry or robo. It is done already in this country. There are at least 20 to 30 case studies with the transfer lines with gantry and robos in the OEM business. And tier 1 companies like Sundaram Group, like Rane Group, Sona Group, tier 1 companies are highly advanced. They are all 10,000 crore plus companies. OEM companies, Tata, Toyota, Volvo, these are the big companies. And they are done complete automation, which I call the 5th level of automation. So all these things, progressive automation, I think the student should understand to see where his jobs are going in the future, right? Now I come to the very, very important thing. I'm watching the time. Now it is becoming 12 o'clock. I will have a hot stop at 12:30 or 12:40. Maybe I'll steal another 10 minutes from Rabindra. But moving faster, right? Automation systems, yeah, are addressing 2 major variables. One is the quantity being produced, volume. Are they producing 100 parts a day, 10,000 parts a day, or 1 million parts a day? It's a logarithmic scale. It's not even a linear scale. It's a logarithmic scale. What is the volume being produced by this company in the factory? Very important dimension, x-axis. Then comes variety. Am I making one type of product, single type ambassador car? Henry Ford said any car is okay so long it is black. Ambassador car, Mark IV. Yeah, Premier Padmini. Only one type of car. Today, there are at least 100 types of cars being produced in this country. And in each car, there are at least 10 variants. So 100 into 10,000 variants of cars. And in every car, there are 2,000 parts. Gears, clutches, brakes, tires, steering, so on and so forth. Imagine the variety that is happening not only in consumer industry, but even in engineering industry like automobile industry. The product variety is obvious in food and beverage industry. It is obvious in pharma industry. It is obvious in other fast-moving consumer product industry like consumer durables, fridges, refrigerators, air conditioners. We understand all this. But even in engineering industry, automobile industry, as I explained to you, the variety is ballooning as we go along. In which case, should we do a simple automation called the fixed automation? Should we do programmable automation? Or should we do flexible automation, right? To explain this slide, I need 1 hour. So I'm not going to take the 1 hour. One video will explain the whole thing with a flexible automation video in the next slide I'm explaining, right? These components, the valves, many varieties of valves, many varieties of turning center turrets, turning center turret, many varieties of engines in a manufacturing sector or even defense sector. These are the examples. My personal example, which I implemented in the last part of my career in Starrag Eckert. Valve industry, machine tool industry, and engine industry in defense sector. You can see 2 machines connected through a flexible manufacturing system, right? And how does this work? Let us see a video.
A year is a long time.
Rabindra, is the
Just
audio
think
audible?
how many hours there
Yes, sir.
are in a year. A month is 30 days, and each day is 24 hours. Altogether, there are 8,760 hours in a year. How many of those hours can you put to good use? On average, only 1/3 of the total hours are productive. However, costs accrue from more than 60% of the total hours. Things can be different. Fastems is the leading supplier of factory automation. FPC, flexible pallet container, a cost-effective investment. With a Fastems FPC system, your workshop can keep manufacturing 8,760 hours a year. The FPC factory automation system is factory tested, easy to commission, and easy to extend. It is a real FMS, with which you can start unmanned production.
Die Engpässe waren dahingehend bestimmt, dass ich die Maschinen nicht so flexibel einsetzen konnte, wie ich wollte. Ich hätte mehr Potenzial gehabt, aber konnte aufgrund besagter Rüstzeiten eben nicht das Potenzial ausschöpfen.
There is no need to stop the manufacturing process for setup changes. Automation frees people from dull, repetitive work and the machine, and makes it possible to focus on more productive work. With one stacker crane serving up to 2 machine tools and 2 loading stations, setup times are almost non-existent.
Well, so you understood the concept of setup time means when you are moving from one component to another component, one fixture to another fixture, when the machining is done on one type of gear to another type of gear, or one type of clutch to another type of clutch, or one type of engine to another type of engine, or even one type of car to another car part, etc., etc. There is a time which is lost due to setting up. You have to set up the machine program, you have to set up the fixtures, you have to set up the man's skill, etc., etc. In this flexible manufacturing system, this setup time is minimized, or I would say even eliminated. In a highly automated flexible manufacturing system implemented in this country, I showed you the 3 examples. The 3 examples. The valve industry, multiple types of components done in the same system, multiple types of turrets in the machine tool components done in the same system, multiple types of engines is a defense industry example in Chennai, done in the same system by this concept. And then the point I made in the previous diagram, flexible automation addresses not only a very high variety in this axis, but also a reasonable level of volume, 10,000 per day kind of volume, right? Or 10,000 per month kind of volume is addressed by flexible automation. High investment of a custom engineered system, continuous production of variable mixture of parts and products, medium production rates, flexibility deal with product design variations. All this we covered earlier. And this is a kind of system which is emerging more and more. Our factory automation engineers have to understand how this system works. And we should be able to design the system. You see how the design engineer is putting this in the diagram. Yeah. This is a FMS system. These are the 4 machines. I did one project in Chandigarh of this nature, right? And many examples. You can see oil and gas sector, tractor sector, machine tool sector, power generation, energy sector. Component parts could be many types, right? There are many names which are appearing here. Mahindra, Ashok Leyland, Tata Trucks, Ace Designer, Engine Factory, already Forbes Marshall. These are real life case studies, right? From my own experience, there are many experience in this country, and we are really going in this direction. And I can tell you, this is the future is flexible automation. Now I want to talk about a new concept called modular automation. Please concentrate on this video. I hope you are making notes.
Introducing the modular automation line of products from Oriental Motor. Modular automation is a rapidly expanding form of automation where traditional assembly lines are transformed into modular assembly lines using automation products designed for DC power or battery input. Modular automation components allow factory design engineers the flexibility in products to design modular and mobile assembly lines, supporting small lot production or a variety of products assembled on the same production machines. Modular automation products are based on battery operation and are compact and lightweight. The global manufacturing situation has changed significantly. Typically, manufacturing has used both manpower and machine. Now, with the shortage of manpower, automation is advancing to solve the problems facing us in the manufacturing process. However, there are some problems with today's processes, such as conveyors that separate the production lines and workers cannot cross in between the lines. For example, if you change the conveyor to a transport robot, the need for an AC power line is not there, and the flexibility and range will expand for transporting products. This allows for the flexibility in the production line layout. Product requirements for achieving a flexible production line layout are battery-driven, DC power input, and are lightweight and compact in size. Introducing the BLV Series R-Type and the AZ Series Mini Driver. Products that provide infinite ideas and possibilities for the next generation of automation. Contact your Oriental Motor representative to learn more about products and services that support modular automation designs.
Well, I think those are all very interesting videos, and modular automation is happening as we go along. And then there is a concept called autonomous factory. Autonomous factory is different from automated factory. Autonomous factory is the one which runs by itself with no human intervention. There is something called lights off factory. That factory has no light on the roof. It's a pitch dark factory. There is a lights out factory in Japan. It's called the Fanuc factory. The factory makes robots, right? And there is a beautiful video, no time to share today. They make all their products, not robots, sorry, control systems, CNC control systems are produced by Fanuc using robots, their own robots. Their own CNC control system, they use robots. It's a lights out factory, no human being. There is only a security guard and there is a dog to support this security guard. That's all. There's only 2 people, right? Even that is supposed to be a joke, because in the modern days, you can replace the security guard with a humanoid there, with an artificial intelligence. Now, friends, ladies and gentlemen, we can say all these are very good for Europe, Japan, lights out factory, blah, blah. How do we bring it to affordable automation in the Indian context? How do we do that? A very few points I want to share in this context for the benefit of those who are joined from the industry side as well as from the students. So small and medium enterprises, what do they do to make it affordable in a good budget where in 2 to 3 years payback period happens? The money put in, you recover within 2 to 3 years. They have to look at what is the essential basic requirements. Essential basic requirements. Don't do something very complex for the sake of that. I learned automation, sir. Therefore, I want to do a very complex thing. I want to put some 4 or 5 robots. I love cobos. Not like that. The basic minimum requirement, the necessary technologies, and also look at the company's budget and look at cost-effective system. If I can do an automation with a low-cost automation, I will show an example in a video about low-cost automation. Low-cost automation, Japanese call karakuri automation. Karakuri. right? You have heard of Kaizen. There is another Japanese word called Karakuri automation. Dr. Devarajan has done many Karakuri automation in TVS Motor in his career. The automation should be simple to install. It should be simple to maintain. It should be simple to operate by the operator. And I should be able to deinstall, reinstall the automation very easily without calling the machine manufacturer or the robo manufacturer. Simple to install, simple to maintain, simple to operate. Extremely important point for MSMEs because they cannot afford to hire a very senior automation engineer inside a small company. Maybe 10 companies together, they can have one person, a shared resource. That's a new model I'm proposing in my MSME forums. A shared resource concept, right? And who's paid by a collective funding system. Even Government of India is funding this shared resource concept, right? Which is called the ZED program. And the fourth is whether I'm using this particular brand or that particular brand or this particular model or that particular model, I must be able to communicate. All the products should be able to communicate with each other. There should be interchangeability, at least communication. What is communication? Data transfer, signal transfer. These are called the communication technologies. We should be able to operate across the products, across brands. And so essential, affordable, simple, and interoperable are the minimum 4 factors to develop an automated smart factory. See, suddenly I bring a new word called smart factory. I'll take 5 minutes to explain the smart factory a little later. But let us look at some pictures. These are Indian pictures. Expensive caged robos. The robo itself feeling very lonely. He is caged inside. Of course, there is a good reason why they are using such large robos. The reach is very important. Longer the reach, we need a robo. The shorter the reach, we can manage with a cobo, collaborative robo. If the weight of the component is very heavy, I need a robo. If the weight of the component is small, low weight, I can manage with a cobo. If I don't need any human interface, I can manage with a robo. If I need a human interface, I need a cobo. You see this, I believe this picture is taken in one of the small rural places in India. I think it looks like South India, not sure. Yeah, the lady is wearing a sari, right? And it is very safe. Normally, in industrial environment, they won't allow a sari. I'm sure it's a very small company. This photograph is taken by a friend of mine. And large enterprises, they try to go for a robos, and smaller enterprises can afford to make with the cobos, right? And 70% value addition, my dear friends, 70% of the value addition in Indian industry happens in small and medium enterprises. Only 30% value addition is done by large companies like Tata, Toyota, etc. It is faster to adopt, easy to learn, maintenance free, and flexible to install and reinstall, redeployment also. I'm not trying to recommend any Kobo brand here. It just so happens that there's one such brand. But the concept of Kobo is catching up more than the concept of the robo. So I call it the flexible automation, appropriate for the Indian industry. And there's some more pictures explaining social distancing. Already we talked about partial automation. That means every process is not automated. Some process automated, worker also has to do some part of the process. Democratized. That means you don't need to, only top management need to learn everything. Even an operator worker can understand it. We can teach programming. You see, she's using what is called the programmable device, human machine interface, to enter the new program. From one component, she is moving to another component. From one shampoo bottle, she is moving to another shampoo bottle. She's changing the program. Let's move on to the Karakuri automation, low cost automation. I will show some video which will explain all this about. This is a Japanese concept, right? Was that video very exciting? Yeah, Rabindra?
Yes, 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 sir.
You see, so far we talk about very expensive things like Robo, Kobo and all. But Dr. Devarajan says, why do you want to do all these things? Simple gravity is given by our Mother Earth is there. There is no drives, no sensors, no electricity, no compressed air. Our friend from Festo and SMC may be a little unhappy. There is no compressed air, electricity. Siemens and Schneider will be unhappy. No drives. All the motor manufacturers will be unhappy. No sensors. Our companies like Pepperell and all those sensor manufacturers will be unhappy. Karakuri automation is the way to go forward for the smallest enterprise in this country. It is very well aligned with the lean philosophy. Lean is not only in production process, it is also in the way you design the equipment. It is so flexible. It is on wheels. I think that entire video explained you. In fact, there is an American company who makes these elements. You know, this picture I will show you. These elements, this American company called SUSAmerica Incorporation. They make these elements. Yeah, you buy these elements, you can make your own Karakuri automation assembly. I'm sure there are people in India who make these elements. But are they really making it for this low-cost automation? I'm not sure. It is a potential joint venture possibility because this company, SUSAmerican, has perfected this art, right? And everything is made under one roof. You can collect the elements and you can make your own flexible automation, low-cost automation, right? The reason I'm showing this low-cost automation, etc., is how to make our small and medium enterprises flexible, at the same time manageable within the budget available. I'm not against robos. I'm not against cobos. We have to go by the progressive automation. Do automation in step by step, earn some money, then invest, then go to the next step, next step, next step. This is how we go. Now, in the next 15 minutes, we will quickly cover a little bit about digital manufacturing and we'll end the session with a job role definition. Let us look at, I'm skipping the video, right? Videos may not make the sense. Industry 1.0, 2.0, 3.0, 4.0. All of you heard about 4.0, but rarely people are talking about 1.0, etc., etc. Very simply put, 1.0 is mechanization, 2.0 with electrical power, 3.0 with the computer-enabled systems, and 4.0 is the internet-enabled systems. Between computer and internet, the digital revolution is to be taken care of. We have to utilize the digital revolution, internet revolution, to build the industry 4.0. Even in 3.0, we had computers, we had robots. But in 4.0, you enable it along with IoT concept, augmented reality concept, machine learning, artificial intelligence concept, etc., etc. And then you bring in what is called Industry 4.0, the real-time connected self-optimizing systems. I'm not going to explain this. This is a master class which Rabindra Saha and other experts will conduct, right? Ayyappan Ramurthy from Siemens, Rabindra Saha from Tata Technologies. They will talk about the real-time connected self-optimizing systems. How does it work? Separate master class will follow. Watch this space and recommend to all the people. And in that context, we are talking about automated production, predictive maintenance using digital algorithms, connected machines. All machines are no more individual. They're all connected with each other. 3D printing is also added as a garnishing to the platform. Big data analytics. Very important to use a cloud-based analytics, millions of billions of data, and smart transport system using autonomous mobile robots, etc. Network supply chain. All your vendors and suppliers can be connected to the OEMs through what is called the blockchain technologies. Production simulation. Several simulation softwares are available now to even find out before even starting the production. So like that, there are many, many changes happening in the industry 4.0. These are only few examples. Now, what should the student learn? My coming to the quick point before I close the session. What should a student learn in industry 4.0? He should learn augmented reality. He should learn artificial intelligence. But before he learns augmented reality and artificial intelligence, he must learn the fundamental science called IoT, Internet of Things. The example of Ola car, Uber car, Zomato, These are all examples of how two mobile phones are connected through internet and you're ordering your dosa. Two mobile phones are connected through internet and you're ordering a taxi. Why not do in the manufacturing system? Within the factory, across machines, across factories of the same company. Branch 1, branch 2, branch 3. Across the value chain of the company, OEM, tier 1, tier 2, tier 3, and a job shop of the same supply chain, let us say car manufacturing. If you connect all the systems and equipment through Internet of Things, the student must learn Internet of Things, in my opinion. He should also learn data analytics, making dashboards. Our friends in Pune, C4I4 teach the students data analytics science. Very important. I know it's difficult to learn. It requires 6 months minimum, but it's worth trying it out. Augmented reality for remote maintenance, remote supervision, etc., etc. Intelligent automation, already mentioned to you that together with automation, how do we bring in digital manufacturing? Even process automation in the office area. Nowadays, we talk about ChatGPT and so many other things. Robotic process automation, RPA, right? These are all very jargons. Don't worry about jargons. What you have to understand, with all these technologies, can I improve the customer satisfaction? Can I improve the quality? Can I improve the delivery? Can I improve the efficiency and cost? And above all, can I improve the flexibility? Right? If I'm able to improve, the benefits are safety, quality, productivity, cost, downtime of machines, delivery, cycle time, flexibility, all these benefits, right? All these benefits. Dr. Devarajan will conduct later on a course on lean manufacturing. I request Dr. Devarajan himself to conduct that course, along with our Mr. Prakash G, who worked in Toyota, now is working in machine tool industry. These are experts. Parasuram sir can add to that panel discussion. How the Toyota production system improve all these things. And today, with automation and Industry 4.0, how do we further improve these benefits? Through data analytic methodologies, through industrial Internet of Things, IoT, through cloud computing, through robotics and integrated automation, intelligent automation, through additive manufacturing, through blockchain technologies, through augmented reality, through simulation solutions, through horizontal and vertical integration, through artificial intelligence, machine learning algorithms, above all, cloud-based big data analytics. A separate class required to be conducted on this. And today is not the main theme for this. Today we are focusing on this small box called robotics and automation. Out of these 10 boxes, we are only touching one box, that too, a basics of the purpose of the automation, robotics and automation. Now I go to the sample job role, right? We have to close this conversation today by giving one sample job role. I think I'm almost on time, right? Let me relax with little water. There are 2 job roles we designed on behalf of a great Indian company, National Forum. And it's good to share with entire system of ecosystem of skill building, right? The more people know this, the better for factory automation to spread across this country. Yeah? Sample job role, factory automation engineer. So far, I think many topics we discussed about the technology of automation and how we should understand it, why we should do it, why we should reduce cost of automation by going low cost automation, and so many other things you learned. Now let us talk about when you join the company. When you join the company, what will be your role in the new company if you're a fresh engineer or an existing engineer? When he goes through all this training, automation training, digital training, smart manufacturing training, etc., etc., how does his new job emerge? Let us see it, right? That is called the upskilling, upgrading of the existing people. So there are 2 categories of training. Reskilling of the new engineer from college, diploma, graduation, even ITIs. There are courses for even 12th pass also. Basic mechatronics we can teach to 12th pass. Smart mechatronics for ITI. Mechatronic along with human machine interface for diploma holder. Mechatronic human machine interface along with intelligent automation, smart manufacturing, maybe for graduate engineer. I'm not discouraging the other people to learn everything. But this is how our curriculum and the academia should structure our courses, from starting from the school pass out to the graduate and the postgraduate engineers, right? Even when we went to school, we started learning ABCD before we learned alpha, beta, gamma. So that's a step-by-step approach in our educational approach, even for vocational practical training. I will read out 4 slides. Don't get bored with me. Slowly I will read it, absorb in your mind. Later on, it will be there in the LinkedIn. There are 4 slides. Why 4 slides? There are 12 areas of the job. 12 job description responsibilities. I'm reading out now. Rabindra, can I read out?
Sir.
This is for the benefit of fresh students as well as people who are going to upskill from the industry. To design and install automation in the process of manufacturing, including material handling, CNC machines, assembly and inspection. Very important is inspection. Metrology automation is a new subject. Assembly automation is catching up very fast. CNC automation is well known already. Material handling automation is well known already. But here the focus, designing and installing. So there should be training courses and designing and installing. Then installing complete lines, including robo, gantry, automated conveyor line with interconnected equipment, fixtures, tooling and gauges. Our company Tata Titan Automation is in this business. They design and install complete lines, including robotics, gantry, automated conveyor lines. That is the automation part. Then the smart manufacturing part, interconnected equipment, fixtures, tooling and gauges. You need to do both. That's a true intelligent automation. For each line I'm reading, you please add 5,000 rupees to your salary. If the basic salary of graduate engineer is 25,000, you please add 5,000 per line. Point 3, evaluate and select electrical control system components such as circuit protection devices, sensors, relays, contactors, actuators, timers, counters, motors, relays, drives, etc. Various types of DC AC drives. Siemens, Schneider kind of companies or the leaders in this point number 3. You cannot teach robotics without teaching electrical systems. To design intelligent, second slide, to design intelligent cyber physical systems. It's a big word, but we are going to include training programs in this area. This is nothing but interconnecting physical equipments and the internet. Cyber is internet, physical is the equipments. Cyber physical system is very important to understand in the digital technology. And several principles of smart manufacturing such as visibility, transparency, traceability, interoperability. Separate modules will be taught here. It can be a 6-week course. It can be even a 6-month course. Point number 4. Point 5, to be the engineering owner of the factory automation. When you join the company, after 5 years or 10 years, you become the owner of factory automation. You can't become from day one. You will have a team of people, and the team of people are coming from the fresh colleges. Drive the improvements of factory automation to meet uptime, throughput, yield goals through control system enhancements. Big sentence. This you will learn as you are going through some MTechs are trying to do this in Indian Institute of Science and directly going to the team leader job. But even them, they need to go for hands-on training. MTech in Indian Institute of Science. Point number 6. To partner in process engineering and operation, test, approve, track any equipment changes to ensure existing logic is robust for new config. Very big sentence. What it means? When you're redesigning the automation, you must know what to change and how to change. Third slide. To be the primary interface, you, factory automation engineer, will be the primary interface with the equipment supplier for all the equipment related issues and upgrade issues. What machine to buy, what robot to buy, what control system to buy, all these things you need to understand. You will be the primary interface. You will be the project manager. Maybe 5 years, maybe 10 years later. I found in the website, a person with 5 to 10 years of factory automation is drawing 12 lakhs, 24 lakhs salary. Some people 36 lakhs salary in India. But you have to make a beginning. You can't suddenly get in 24 lakh salary without knowing the fundamentals. To define the requirement, design, test, employ, support new factory automation, industrial internet. Very big sentence, right? See, I always combine the automation and IoT. This job description was designed 5 years back. It is still valid. Point number 9, to develop a robust and cost-effective digital spare parts strategy for equipment. There's no point in doing automation without maintenance. For maintenance, you need spare parts. And digital spare parts. What do they mean by digital spare parts? Additive manufacturing, 3D printing is also coming in the manufacturing of spare parts. Very quickly, you can make it using 3D printing. To assist on-ship maintenance technicians solving automation and cyber physical system issues. And last slide, to create documentation to support maintenance activities of the equipment. Very obvious. Standard operating procedures, troubleshooting guides, preventive maintenance procedure. We have to teach in training also. To assist in the training of preventive, predictive, breakdown maintenance staff to support the repair of the equipment. Big subject. Everybody talks about automation, nobody talks about maintenance. To assist on-ship maintenance for solving automation issues, already covered. To create documentation, 13, 14 is repetition. So, I think I will skip the sample job role of digital manufacturing engineer. It's a big subject, but I will come to do this, what should we learn in the next 5 minutes? We have to learn about Internet Communication Technologies, ICT, Information Technologies and Communication Technology. You have to learn how to manage data, how to handle data, how to work with data. You have to learn technical know-how. All that we spoke in the last 1 hour is all technical know-how. Apart from all these 3, you must have a personality skill. Our good friend Magesh Bhupati talked about soft skills. Adaptability and the ability to change. Non-automation, automation. High cost automation, low cost automation. Automation, digital manufacturing. Ability to change. Decision-making skills, working with the team skills, communication skills, mindset change for lifelong learning. Mindset change for lifelong learning. Personality skills. To this, if I go to Devarajan and Parasuram, he'll say, please add the best practices. 5S, Kaizen, TPM, TQM, quality circle, problem solving tools, A3 page, 8D analysis, and 7QC tools, and so on and so on and so forth. For manufacturing people, the personality skill is not only this. It is those things I talked about improving the manufacturing culture. About these 3, there is a detailed chart. I'm not going to read it. It will be there in your LinkedIn. You can go through. This is developed by a global German organization. Global German organization. Cognitive analytics, big topic. Content skills, how to make PowerPoint chart. Process skills, physical abilities. It's not a desk job like software development. It's not a desk job. You have to be in the shop floor. Physical abilities, dexterity, complex problem solving. Very, very important. This box. Among all these boxes, I give the highest importance to this. Complex problem solving. Problem solving, we understand, Kaizen and all, but complex problem, how to solve? There is a method called differential diagnostic. Differential diagnostic. Very important in pharma industry. Very important in chemical industry. Nothing is visible. All are inside a vat or inside a chamber. You cannot see what is going on in the chemical industry. You need a differential diagnostics. Process sector automation is very more challenging than discrete manufacturing automobile sector. Other things are very obvious. Social skill, resource management technique. And these things, white box is ability, light blues basic skills, dark blues cross-functional skills. Thank you very much. With that, I'm going to unshare. Yeah, I don't know how to unshare. Let me see. Have you unshared?
Yes, sir, you have answered.
No, unsharing ho gaya or still the slide is visible?
Yes. No, slide is not now visible. You are only visible, sir.
Slightly exceeded the time.
It's almost right. But thank you so much for, sir.
90 minutes. See, 90 minutes. Right.
Sir,
Thank you, sir. Next 20 minutes we have, or maybe another 10 minutes also. People are interested. Still we have the 25 people. Nobody is left or somebody is joined. Right. Okay.
Yes.
I'm
Shall
all
we
yours
start,
now.
sir?
Yeah. Please.
Sir, first of all, sir, thank you so much. I was so passionately listening to you, each and every words, your experience, your guidance on technology domain and ahead is awesome, sir. Best of best. I have seen the kind of practical
I'm humbled
experience
to
and
hear
guidance
this
to
from a great Tata Technologies chief engineer.
So a lot of learnings I have got. I have also noted how many points. And I keep on seeing on the chat box and see that a lot of good words are coming from the participants. And someone says that nice session to open students to a 360-degree viewpoint and perspective. So that's the kind of the feedback and compliments, sir.
I feel a little sad that the phenomenal number of colleges are not joining these sessions in spite of BCIC spreading the message for over last 2 months, right? That is the sad part. They all want to go to IT industry. Why? That's my first question in the Q&A. Right, sir. Go ahead.
So, and yes. So one more, I see the comment, very good session, well designed, very informative. Thanks to BCIC team and Mouli sir for the arrangement. That is another, I'm just reading out. There are many questions and the compliments, sir. So I'll start with the few questions, whatever time you can permit. The questions from Magesh Bupati. Just would like to understand more about what could be the job profile for digital design engineer. Digital design engineer, job profile for digital design engineers.
Yeah, I think that was not the subject of the day, but anyway, I will try to touch upon that. See, as I mentioned, design cannot be a standalone silo. Design engineer should understand how the manufacturability of the design is happening. Can my design be manufactured easily or not? Once the manufacturing is over, can I do the after-sales service properly or not in the field? In my machine tool experience, I found design engineers are working in silo. Manufacturing assembly people are working in silo. Service people are working in silo. Connecting these three was done by leadership people. Connecting these three are done by supervisors, general managers, vice presidents, and CEOs. Why should we do that? A digital design engineering concept connects all these dots through what is called the product lifecycle management technology. Rabindra Saha will have a separate session on it. And that person, this digital design engineer, of course, he will specialize in design, but he will have a far-reaching understanding of manufacturability and serviceability. I will add one more point, the feedback mechanism, what is called the closed loop quality feedback. Design to supply chain to assembly, assembly to after sales service. Then quality problem happening in every stage. That quality is feedback to the design. Design engineer makes a modification. When he makes the modification reaches supply chain people, it reaches the suppliers, it reaches the assembly machining, it also reaches the after sales service. Does it happen today? No. We are still working with old design drawing in the shop floor and the big jagada happens. Monday morning meeting, sunrise meeting, etc. Sorry. The digital design engineer have to learn the whole thing. Thanks for Magesh for this question.
Thanks, answers. And one more question, what is the level of threat? What is the level of threat from internet to industry 4.0 in terms of server crash, glitches, or hacking?
See, Manas Dasgupta should do a cyber security for manufacturing. Please talk to him. Manas Dasgupta is an expert in cyber security. For cyber security, he has been doing for retail sector. Let us do cyber security for manufacturing. A simple answer to this is anything if the data corruption happens, the machine, instead of producing 2 micron accuracy for a helicopter gearbox, if it produces 7 micron accuracy for the helicopter gearbox, what will happen to the helicopter being produced by HAL? I have supplied one machine to helicopter industry in HAL, Bangalore only, which can produce 1 to 2 micron accuracy. If the cyber security threat happens, right? And
Yes,
if the
sir.
data, what will happen to the production of that machine? Machine may be capable, but the closed loop quality feedback required for the corrective and preventive action, it's a big subject. My good friend in Ludhiana has launched for alloy wheels a closed loop quality feedback cellular manufacturing. There is a robo in between. There are 3 machines. And there is one more measuring gauge, automatic measuring gauge in between. Separate station for gauging, auto gauging station. He also supplies it. He supplies machine, he supplies the robo, he supplies the thing, but of course he buys the robo and all. These cells have become so popular across this country. He has got a leadership position of 40% market share for alloy wheels. All automobile alloy wheels. Small company, 60 crore company. He is producing this solution for alloy wheels across the country. Machine tool company. The feedback mechanism from auto gauging back to this machine, and hundreds of machine cannot happen by wiring. You have to have internet enabled system. And cyber security, if it is not taken care, there will be chaos. In pharma industry, I don't know to tell you. Instead of making Dolo, you may end up making some other tablet.
Yeah, thank you, sir. Sir, Dr. Devarajan sir just added in the WhatsApp, rotation among the different departments with customer focus will make engineering all round and ensure digital applications more. Thank you, sir. Thank you. Thank you.
No, that is not only a comment, it is also a question. Why I take it as a question? So that I can give you an illustration. In one industry, I implemented what is called plant on wheels. Abbreviated POW. That time prisoners of war was very popular. So Kargil time. Plant on wheels. POW. What we did, the factory people, many people from assembly line were sent to after sale service. Designers were sent to after sale service. 3 महीना करके आ जाओ वापस. Thank you, Devarajan sir. This is extremely important. OEMs can afford to do this. Small and medium enterprise, अरे मेरे पास आदमी नहीं है किस कैसा भेजूंगा. So he has got another problem. Fair enough. But large enterprises can take a lead on it. Always sunrise meeting, Monday morning meeting. छोड़ो यार. Let us do PLM. Let us do POW. PLM is a digital method of communicating. POW physical method of communicating. उसको उधर भेजो. Then in another company, Dr. Balamurugan is here, is listening. What he did an innovation. He brought the service people to factory. 40 people from service came to factory, studied all the problems in the initial production. PPAPs. During PPAPs, is after sale service dealers, are they coming to visit TVS Motor? Are they coming to visit Toyota? Are they coming to visit the EV produced by Tata? Nexon. After sale service people should come to assembly line and make comments. We did in machine tool industry. Balamurugan is listening. So main point is plant on wheels. I agree with Devarajan sir. A cross-functional team and a cross-functional exposure is very important. Above all, it will result in multi-skilling and multitasking. My famous theory about multi-skilling and multitasking is because of this reason only I have been talking about this. Thank you, sir.
Thank you, sir. Sir, I move ahead. There are many questions floating. Just I'll take another question. What is the main role of a process engineer? What is the main role of a process engineer? What factors used to be considered while designing the process and the automation of the process? Probably parts you have addressed.
No, excellent point. See, the erstwhile manufacturing engineer, one of the subset of the manufacturing engineer job role is process engineering. He is looking at the entire process. I had a friend called Praveen, KS Praveen, Makino. Right? Today's president of Makino, Mr. Dago Badia, is once upon a time process engineer. Great process engineer. So process engineering is nothing but ensuring the entire sequence of processes with the appropriate quality parameters, input parameters of the man-machine materials, output parameters of the output, inspection parameters, and cycle time, etc. defined. Process chart bana do pehla, flow chart bana. Then bring in the fixture design, tool design. And then the metrology, inline gauging or online inspection, Renisha, probe, etc. The whole gamut of things. I put in a simple thing, if the students, they can understand. Man-related aspects, machine-related aspects, material-related aspect, method-related aspects. You put it together into one chart. That is the process engineering for a layman's explanation. And then how to make automation. Automation is nothing but part of the process. Instead of, if I don't do automation, it's a process, manual process. If I do partial automation, it's one process. If I do full automation, it's another process.
Thank you, sir. Thank you, sir. Many questions. Now I take another. What is the role of AI in industrial automation?
Excellent question. See, I've been scratching my head. Modi Saab also talks about AI. Nirmala Sitharaman talks about AI. Other day, somebody talked about AI must, Skill Academy should introduce AI. What AI? Then I thought there is a very doable aspect called machine learning algorithm. Another doable thing called vision-based technology. Let us start with these two in automation. Vision-based technology with metrology, I saw in CMTI. Fantastic, they have done. Predictive maintenance has been implemented by MaxByte, Mr. Ram Shankar and company in Coimbatore. Small and medium enterprise, MaxByte. Algorithm for supply chain management has been implemented by Larsen and Toubro. Mindtree. Large companies are looking into algorithms. TCS, Mindtree, all these people. Right? The algorithm is nothing but creating a pattern from past experience, current experience, projected to the future. I'm saying layman's terms for the students. Even I only understand that much only. Even my understanding of algorithm is only that. Create a pattern from the previous data, very complicated pattern. It is not some XY small two-dimensional chart. No. It's a very complicated multivariate analysis. BCIC last year did a program on that. Let us do a program on machine learning algorithm for manufacturing. Rabindra sir, please note it down. Machine learning algorithm for manufacturing, not for retail sector and other thing. And vision-based technology is very, very useful. The third area I want to talk about, which nobody has done in India yet, is machine learning algorithm for supply chain problems. Delivery problem, quality problem. Tata has got thousands of suppliers. Toyota has got thousands of suppliers. You can't manage with ordinary technology. You need proactive supply chain quality management. I use deliberately the word proactive. I didn't want to use a predictive. Predictive is a dumb approach. Proactive is a better approach. The hub and spoke model being implemented by Mr. Parasuram and Devarajan for OEM and supply chain should address this proactive model for supply chain. Only machine learning algorithm can help us in this, along with blockchain technology. Thank you, sir.
Thank you. I take a few more questions. We have time.
Sure.
10 minutes.
Until my lunch is getting ready.
Many questions you have already answered towards the end, but one question is specific to the startup. Can industrial automation enhance MSME and startup success? Or is this only for the grown companies?
I tell you, we have been always thinking that it is not affordable, etc. I gave many examples of affordability. Even digital technology, how to make it affordable. You see, softwares are now available like an app. A company called PTC is giving augmented reality as an app. That app is called Vuforia, V-U-F-O-R-I-A, Vuforia. It's just an app. I have downloaded, you can use it. So time has come, we should not think, oh, digital technology, mehenga padega, thousands of crores. No. One example. Second example, our friend MaxByte has done condition monitoring, energy monitoring, and OE monitoring into one package, right? Without his permission, I can even tell 999 rupees per machine, including hardware plus software, right? There are many examples. Somebody else may be doing at 300 rupees also. I don't know. So if I do these three minimum things for a CNC machine, our AMIT AS designer have done fantastic work on spreading this in small and medium enterprises. Jyoti CNC has done a fantastic work on small. Why? Because they supply 4,000 lathe every year. Who is buying 4,000 lathe? Turning center. One company supplying 4,000 turning center every year. 10,000. Who is buying? Only small and medium enterprises are buying. So they make a package: condition monitoring, OE monitoring, energy monitoring, hardware, software, sensors. Machine ke saath de do.
So there is some specific question.
But I want to make one more point.
Please.
The initial thing, I visited a MSME in Hosur recently. They are still writing everything in logbook. 50 micron plus minus 10 micron, component number 3, 50 plus minus 5, component number 4. Come on. MSMEs task digitizing. The starting point is computer le lo, digitize karo. Don't do any automation, don't do any IoT, nothing. Start paperless production, shop floor. It's a 100 crore company. I visited in Hosur. 100 crore company. Everybody writing logbook. In quality department. Forget production department. They have a CMM, they have metrology, everything they have. But he's writing in logbook, handwritten. Come on. MSMEs, please wake up. Next one.
In fact, the question related to the same. Any maybe you partially have addressed, but any roadmap for factory automation? Any roadmap for factory automation leading to a smart factory with or without minimal disruption to production business disruption? More so for MSME.
Very long question. Can you repeat that? Summarize it.
Yeah, I'll summarize. Is how the factory, what could be the roadmap for factory automation leading to a smart factory with or without disruption of production business disruption?
Okay. I just read it. Sundar, NP Sundar. My good friend NP Sundar. He is a great man from Reliance. He is a walking library of process automation and maintenance of process automation. We should call him for one masterclass.
Sure.
He has already got his material ready. He is the number one person in process automation and maintenance of it. I can vouch for it. NP Sundar sir, the roadmap is Pehla computer Kharid lo. Tell the MSME first computer. Just now I mentioned. The Edutech University has made a beautiful roadmap for this. Starting with computerization. Next step is connect the equipment. Horizontal integration, vertical integration. And third step is create the transparency and visibility. Make some dashboards. Measure some KPIs. Fourth step is traceability, backward traceability. Closed loop quality feedback. And finally, they bring in the autonomous factory where self-control automatically, that too far away to achieve. Even that paperless office in Japan has not done it. So these 6 steps are already defined by the Edutech Association University, and that is a document available, public document available. And those are the roadmap, right? C4I4 in Pune has made a 3-year roadmap for smart factory enablement.
Thank you, sir. I'll take 2 more last questions.
But the $1 million question is without disruption. He has written there without disruption. I'll tell you how. Yes. Yeah. Create a pilot factory, pilot laboratory in that own company. Ask them to offer one small department. Ask them to offer one machine. Ask them to offer one assembly line. I went to one Chennai company. There are 10 assembly lines. They said, no, we cannot disturb. Oh, no. Yeah, I agree. Can you give me one assembly line? Yes. One assembly line they gave. The ones they taste the blood. When the tiger tastes the blood, what happens? You know, it goes into the forest and grabs all other animals. Then MSME mind is open. The problem is not disturbance. The problem is mind by the top management. You do prototype, they say, think big, act small. is a big subject. Digital transformation is a big subject. Even the Siemens and Bosch of the world are struggling and frustrated. Frustrated people in Siemens and Bosch. Why? People only think big and act small, and they continue to act small. But difficult, I know. So how to make it affordable? Siemens and Bosch should think, can I make a special package for MSME? Can I use startup companies to lower the cost? Instead of putting an expensive Bosch man, Siemens man, Schneider man, can I use that low cost man from startup companies? Can I develop like TVS Motor develop thousands of manufacturing MSMEs, tier 1, tier 2 companies? Can the digital industry create hundreds of tier 1, tier 2 companies? Can Tata Technologies create hundreds of tier 1, tier 2, tier 3 companies and reduce the cost and reach? When you have so many companies making digital technology, chota company with 10 people, they can go to the nook and corner of the country and implement in MSMEs. When will that happen? Who will take the lead? Bosch, Siemens and Tata Technologies have to take the lead. Thank you, sir.
Thank you. Sir, one more question. Software languages used in robotics and automation.
Very softly, I would like to admit, I have no idea.
Okay. We'll revert back to him. Emerging roles.
The answer is every company with the respective products. Makino CNC machine, Makino software is available. Mazak CNC machine, Mazak software is available. Why do you want to reinvent the wheel? Robo programming, Robo software is available. Fanuc has got his own software. There is no sector agnostic, brand agnostic software hitherto available. If it is available, Devarajan sir will know. I don't know it.
There are a lot of open softwares now. Everything is available now. No problem at all. Yeah.
I know. Yes and no.
Yeah.
It's just emerging.
Sir, I'll take last questions and then emerging job roles in automotive industry related to industry automation. Probably you have covered, but would like to say something, sir?
Maybe that question they asked in the beginning. I think the session has answered it. The top 10 job roles have been listed. There are 45 job roles, right? The most important is let us create smart mechatronics engineers. Not ordinary mechatronics engineer. Oh, jamana gaya. Now I want IoT enabled, sensor enabled mechatronics engineers. Oh, pehla karo.
So with this, I think we are towards end. But there is small questions I would like to answer. What about next version of Industry 4.0?
No. That question I will refrain from. See, to talk about Industry 5.0, 6.0, there are a lot of pundits in the academic area. Let us first of all do 3.0 here. I deliberately refrain from that question. I get that heckling in every forum. With due respect, I am telling this. But I want to take the other question which you didn't read. Can automation help quality and consistency in MSME? Dr. Devarajan himself has asked this. Thank you, sir. Wherever I go, I tell, don't do automation for productivity. Don't do automation for delivery. Do automation for quality.
Even justifying automation is justifying by improvement of quality, improvement of rework, consistency of output. If you don't meet, what are the loss of production? What are the loss of business? I think the change of return on investment is changing now. Let's not think investment is big. Let us talk about the output, what you're going to get in terms of the quality, in terms of the consistency, in terms of the people, and in terms of loss of business if we don't do it. I think the change, our mindset is getting changed now, and we are trying to push our suppliers also in a similar way. They are understanding it better. I think it's a movement. We have to take the first step forward, understanding it, implementing it, like what Chandramouli did say about making a small unit, show the benefit of it, and people will pull continuously. I think it's first of all, Chandramouli, an outstanding presentation of yours. Very
on
clarity.
That question, before you give the vote of thanks,
yes, sir.
10 seconds, you motivated me for one answer. Yes. The quality measurement has got two dimensions. If the respective tier 1, tier 2, tier 3 can get more business by improved quality, the MSME gets more cake, more business, more turnover due to improved quality. That is one dimension on the revenue side. Then they might say, sir, my business is taken over by the other person. The market competition, then I lost the business. No. G20, G21, we will get orders from Africa also. Yeah, you think African Union, Modi Sahab did just like that, not a political statement. Africa is a huge potential market for our country. Devarajan sir is already working with Mauritius and other people. So, cake, revenue growing. Second area, when the quality explodes, Europe and America will not buy any more from China. They will buy only from China quality. You cannot say it's bad. Huh? All of us, our phones are all made in China, right? Don't keep saying Chinese quality. I found 20 to 30% of machines last year imported into India from China. I was shocked to know this. 25% from China. After the next only to America. Sorry, Japan, Germany and America. Korea and Taiwan has lost out to China. Second dimension of this quality, Devarajan sir, is a cost of quality. If you reduce the cost of quality, cost of rework, cost of repair, cost of rejection, cost of warranty, cost of hidden cost of lost business, etc., 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 huge amount adds to the bottom line. Phil Crosby said 40% of the profitability is in cost of quality. He said it 30 years back. It is still true. So revenue improvement, cost of quality. My dear MSME, please look into only digital solution, automation solution for this one benefit. My appeal, quality. Forget about all other benefits. Thank you, sir. If everybody is allowed to open the video, we should have a beautiful screenshot by Rupa.
Yes, all participants, please switch on your camera. As per the speaker, we will take a picture. Can we switch on camera?
Wherever possible. Maybe it's locked.
Wherever possible. Wherever possible.
Okay, I think we come to the hard stop.
Yeah. Okay. So you wanted to say, sir, sir.
No, I think camera is locked. Rupa has to unlock the camera.
No, it's open. It's open.
It's open. It's open.
Yeah.
Balamurugan wanted to open.
I have enabled, sir.
Ram Rohit has opened. Sundar has opened. My friend Sundar, you lost some more hair, sir.
Yeah.
And,
hello, sir. Yeah.
Pravesh. Bhavesh Prajapati, Tata Insurance Skill is open. Oh, Anup Vadvaji, my Guruji. Vadvaji, my Guruji, who has done a fantastic digital automation laboratory for training MSMEs and large companies in Delhi, IIT Delhi. Thank you, sir, for joining. Magesh Bhupati, struggling with training curriculum. Thank you, sir. Okay.
Thank you all. Thank you all for joining. Thank you all.
I think great names. Balamurugan is unable to join. Oh, Harish. Wow. Harish, sir. He's a mechatronics global leader has joined. Rachanani, sir. Thank you, sir.
Thank you, sir. Thank you.
So we have the great leaders in this country, in this forum. Next time around, so Rupa is promising 1,000 students will join this course. Not 100, 1,000.
Yeah.
Sir, in fact, I would like to share that this is being streamed in the classroom, sir, for the students.
Excellent.
Instead of one.
Acha.
Yes, sir.
I see. Okay, it goes in the screen. Okay.
Yes, sir.
Excellent.
Fantastic.
So this is the first time the session is being streamed in the classroom.
Excellent.
Very good.
Excellent. Yeah.
Then let us talk about 100 colleges.
Yeah.
We have to measure.
Rupa.
Yeah. Thank you.
Yeah.
Yeah,
thank you very much, sir. As in the past, and this is really an exhaustive and knowledgeable session. Thank you very much, sir. And I really feel privileged and honored for being part of this education journey, sir. And thank you, Mr. Rabindra sir, also, sir, for initiating and structuring this session. And I express my sincere thanks to all the distinguished experts who have joined. And we also look forward to have you in our session, sir, going forward. Thank you once again. And thanks again for all the participants.
Please share this to all. Please share this to all. Thank you.
Yes, sir.
The video will be shared and also
we want more membership. We want more people to come in. We want to share more. So take this opportunity to share this more and to be in the YouTube also. Thank you.
YouTube and LinkedIn. And there will be 12 more sessions coming in the next 12 months. Thank you.
Yes. Yeah. Thank you, sir. Thank you very much. Thank you all.
You all.
Good day.
Bye-bye. Have a nice lunch.
Bye.
Thank you.